finish off the integration topic, we're going to talk about differential equations. Now, typically differential equations require you to have some additional information for this problem to be solved. So in this question here, I'm gonna walk you through it and show you what I mean. So a spaceship accelerates from rest. Its velocity can be modelled by v equal to 4t cubed. And we're asked how far will the spaceship travel in the first 5 seconds. Okay, so let me show you how you're going to work this out. So what does this look like? Well, how far will it travel? So let's just say s for distance or displacement. So what we're saying here is we know that velocity is equal to the change in distance over the change in time. Okay? We know that is equal to 4t cubed. So what we want to do is to get this into a more recognizable form. So what you do is you multiply by dt. So you're left with something like this, equal to ds is equal to 4t cubed dt. Okay, now this looks like something that's a bit more familiar. Get rid of this thing out the front. So now you're left with this. Okay, well, this looks pretty simple. If I want to get back to this expression s, all I need to do here is integrate with respect to t. So this gives me this. So I'm left with s is equal to 4t to the power of 4 over 4 plus c plus your constant of integration. Right, these 4's cancel. Very nice. Equal to t cubed, or t to the power of 4, not cubed, plus c. Right, so how does this help us? Right, we're left with this. We want to know how far it's travelled after 5 seconds. We put 5 seconds in there, but we still got this plus c, which we don't know what that number is, right? So how can we figure it out? Well, if you read the question again, it says it accelerates from rest, right? So from there you can deduce, okay, well, from rest means it's not moved anywhere. So if s is equal to 0, right, when t is equal to 0, we can substitute that into this equation. So this becomes 0 equal to 0 to the power of 4 plus c. Okay, so c for this specific equation must be 0. Therefore, c equals 0. So s is equal to t to the 4. We're not quite finished yet. So it wants us to say how far will the car travel in the first 5 seconds. So s of 5 is equal to 5 to the power of 4, which is equal to 625 meters. Okay, so there's your answer. What about another example? So here, find the solution to this differential equation. So we're saying when ds by dt is equal to 3t squared plus t minus 3, and we're told that if s is equal to 0 when t is equal to 2, right? So maybe that will come in handy later. So it wants us to find the solution. So let's have a look. Change color. So again, I want to write this as ds equal to 3t squared plus t minus 3 dt, right? And then I want to integrate this, so the d's disappear, so I'm just left with s equal to 3t cubed over 3 plus t squared over 2 minus 3t plus c, right? The plus c here is really, really important because that allows us to figure out what was going on in the first place. Right, so let's have a think. So first of all, these cancel, which is nice. And we're saying when s is equal to 0, s is equal to 0 when t equals 2. So if we can say, okay, well, we put 0 in here, I'll change color. When 0, then we're saying, okay, that is true when t is equal to 2, and that's cubed. Okay, plus 2 squared over 2 minus 3 times 2 plus c. This is going to be equal to 8 plus, that'd be 4 over 2, so that'd be 2 minus 6 plus c, right? So that's going to be equal to 8 plus 2 is 10, minus 6 is 4. So 4 plus c is equal to 0, or 0 is equal to 4 plus c. Therefore, c is equal to negative 4. And what you can do is to bring this back in to your equation. So let's go for different color. So therefore, s is equal to t cubed plus t squared over 2 minus 3t minus 4. And that's your final answer. There. So there you go. That's the idea. You want to take something, you want to take these conditions and then substitute that in to get your final result. So we might do a few more examples, but this is the idea.